Hey guys, for today's experiment, we're going to be creating hydrogen and capturing it in a balloon. So I've created this apparatus that you see here. I've got two 500 milliliter Erlenmeyer flasks. It's important that they are heat resistant because this is an exothermic reaction and it will generate quite a bit of heat. So what we're going to do in the first flask here, we've got 200 milliliters of water and we are going to add some sodium hydroxide crystals to it. This is caustic soda. We're going to add about 2 spoonfuls of that into that mixture and slosh that around until it dissolves nicely. And then we're going to drop some aluminum foil pellets into it. The aluminum foil will get eaten away rapidly by that solution, and as it does so, it will off-gas hydrogen. The hydrogen will be about boiling temperature because it will be boiling in here. And you'll see the gas is going to escape up through the top of the stopper, through our tube. Then we have a second flask just filled with cold water. So the gas is going to come down this tube, which is underneath the water, so that hot gas is going to condense any steam, and it's going to stay in the water so that the gas that comes out and bubbles up to the surface is pure hydrogen, and that will be collected through our last stopper and into our balloon here. So we're going to go ahead and set this up outside because it's a little bit dangerous to do inside, and we'll be back with you when you get out there. Okay, we're safely outside and ready for our next step in this experiment. So we have our cool water in our flasks, got our apparatus ready to put in position once the action starts happening, and now all we need to do is mix up the solution. So this is a hazardous material, so we're going to be very careful with it. Seal up the caustic soda. Now as we start to mix this in, just the simple amount of chemicals that are in the tap water that we used are already causing it to generate heat. So this is already becoming lukewarm, and once we add the tin foil, it will get a lot hotter. So we've got a little bit of time to allow this to dissolve. As you can see, we've still got a few crystals on the side as well. I'm going to try to mix those in, but I definitely don't want this to splash out of the flask. That would be a bad day for everybody involved. So there's our solution. It's looking good. Let's add our aluminum foil. Takes just a minute to get started here. And while it does so, I'm going to go ahead and cap it off. Put the stopper in. Now we can see in the other bottle that we're starting to get some air bubbles accumulate as the reaction starts, and that's going to speed up and get quite rapid here in a little bit. Water temperature is already about 90 degrees. So that's just getting hotter, and you can see it's just getting started, and our balloon is starting to fill with the hydrogen gas. And we started this with air trapped within both our second flask and our first flask. So there's a mixture of natural air, which is nitrogen and oxygen and everything else. I did that on purpose because for this experiment we're actually going to be igniting the hydrogen in this balloon, and I'd like there to be some oxygen in there to make a little pop when it ignites instead of just burning slowly. Now in a stronger solution, this could take as little as 30 to 60 seconds to inflate one balloon, but that happens so quickly it gets difficult to handle all the parts, and it's spraying some pretty hot steam out of the top of the bottle, which we want to avoid here while we're trying to capture it in a balloon. And ideally we're just getting pure hydrogen now into the balloon. Most of the gas that's in the two flasks should have passed through. But as it goes along, the amount of hydrogen being added will be more and more pure as the flasks are vacated of the other air. So the reactions continued for about another minute, and you're starting to see a discoloration in the solution on the left. This is as the aluminum foil dissolves, it leaves residue in the water, and that will start to discolor that water and eventually become nearly black, or dark gray water. So we'll see that towards the end of this reaction. Our second flask looks to be doing its job. The water here is still very cool, and we're not seeing steam at the top of the flask, even though there's some condensation on the sides. It looks like it's cooling that gas appropriately, so that we're just getting gas and no steam in the balloon. So this reaction is happening about as fast as I expect it to be going during this experiment for the strength of the solution we mixed up and the amount of aluminum foil we have in it. So I'll give you a close-up here so you can see just how that looks. Okay, so our balloon is about a third of the way full. You can see the reaction is going along quite nicely. Our water is clear here, which I'd like. The first flask, the water is quite dark, and it's actually dissolved the aluminum foil to the point where the long piece that was partially out of the water has now fallen completely into the water. So it has sped it up a little more as there's more aluminum foil in contact with that sodium hydroxide solution. That clicking sound you can hear in the background is actually the bubbles, the sound of the bubble vibration being carried through the surface that we're on. If we lift it up, it stops. And temperature-wise, we're generating quite a bit of heat here, and you can see the steam rising up from the aluminum foil as well. Now when the balloon reaches the size we'd like, what I'm going to do is pinch it off right there at the base so that it'll build up pressure next to the stopper, which will help it come off the stopper easily. And then I may stick that second balloon on and just see how much more gas we can generate from the reaction we have going right here. Now if you try this experiment yourself, one thing I would caution you is to make sure that the stoppers you place in the flasks are firmly in place, because as the pressure builds in the balloon, it's building pressure in the entire system. And you could easily blow the top off of one of these and it could spray some steam out, which is a little bit caustic, so just watch out for that. Okay, our sodium hydroxide solution has almost completely dissolved the aluminum foil that we put in for this experiment, which is just about the right amount to fill one 9-inch balloon. You can see that our reaction is now going a little bit slower as there's less aluminum foil to react with, but the balloon is reaching the size that we would like to have it at before we ignite it. Obviously we're not going to ignite it while it's on the apparatus, because the flame would actually follow the path of the gas back into this bottle, and it would blow the top off the bottle or possibly crack the bottle. The water would keep it from going back in through the tube and into the first flask, so it would just be the second flask that would be at risk if we were to ignite it as it sits right now. Okay, I'm going to go ahead and try to remove the balloon. Just pinching gently and letting the pressure build up on the other side, and while I do that I'm going to roll the edge of the balloon up. Okay, and we'll go ahead and tie that off. You can see the balloon does float. It's lighter than air, which is one way we can confirm that we have hydrogen in it. So it does float by itself. If I were to let it go, it would go up. But we want to keep it down to earth for our little experiment. Okay, we've started our second balloon by adding a little bit more aluminum foil into the solution. Now this reaction happens quicker when the liquid is hot. And because it's already heated, we're seeing a very rapid reaction, and rapid release of hydrogen gas into our balloon. So we'll let that run for a little bit and inflate that balloon, and it's about time to get the matches. Okay, you can see from the reaction that a fair amount of steam is still being generated in our first flask, and it's actually collected in the tube, and you can see it build up to a little droplet and keep going up. It's almost making it to the top, so that's going to start contaminating our water over here. The first flask is quite dark. It's pretty much impossible to see through, and the reaction is just starting to slow down here, but our balloon is good size. So we're going to go ahead and remove that one, and we'll ignite both of them.
Whoa! That was awesome!
So our experiment was a success. We were able to ignite both of the balloons and got a pretty satisfying pop from both of them. That sound you hear is the hydrogen mixing with oxygen in the air around it. Had we inflated these balloons with an exact mixture of 2 parts hydrogen to 1 part oxygen, the ignition would have been supersonic, and it would have sounded much more like a shotgun than just a boom like that, a soft boom. But it was still a lot of fun, and it was one more way to verify that the gas we had in those balloons was hydrogen, because hydrogen is flammable. Helium is not. If you want to do this at home and you have access to a lab shop, 2 flasks, Erlenmeyer flasks that can handle the high heat are all you need. I use 500 milliliter flasks for this. I got 3 stoppers. One of them has a single hole and just a little angle plastic there, and then some surgical tubing to go between it. And the next stopper that goes in the second flask has 2 holes, one to a pipe that goes under the water, and one to the other stopper that I use to inflate the balloon. So materials wise, it's pretty simple. The key ingredient is the sodium hydroxide, which can be found in a lot of chemicals in the local hardware store. So do your research on that and make sure you know what you're getting. It is dangerous. It can be quite damaging to your skin and your eyes and everything else. So you do want to be careful with that. This isn't something to try on your own without some professional supervision. Other than that, just a balloon, a match, some string, and you can impress everyone with your knowledge of how to create hydrogen. So for now, that's our experiment for today. I hope you liked it. If you have any questions, leave them in the comments below. Feel free to share with your friends, and let me know what you want to see next.